Hello everyone, I'll be discussing RMO 2023 question paper with you. But in one session only, I won't be able to complete because RMO questions need your full attention to solve. Before you solve, you must read the problem carefully, find the information given in the sum and then proceed. This year's RMO question paper, I have seen problem number 2 and problem number 3 were very easy to start because those questions are fully concept of class 9 and 10 geometry, some extent class 8 theorems also there. And I tell you, those who have solved at least a reasonable part of the sum, they will be getting marks. As this one is a descriptive paper and each question 70 marks allotted, 17. So this is true that if a student has started properly, few lines were correct, his or her approach were correct, then some marks will be given. This is the rule of a descriptive paper. And I have the past experience, so I am sharing with you. If you have done half of a sum even, you were not able to complete, you can expect some marks, but till that part, half of the portion should be correct, so that people come to know that you know how to proceed. Might be due to some reason you are not able to complete. Memory based sums are never asked here. Everything you have to think, and finally you have to solve based on the information given in the problem and the theorems, important theorems, whatever you did in class 8, 9 and 10. Then you will ask me how a class 8 and 9 student will answer the question. Listen, those who are going to appear for regional maths Olympiad exam, they have qualified IOQM, that they know what to study for a Olympiad based examination. School based geometry is just ABCD to start. But apart from that, some portion there which is deleted by the board, questions will be asked in Olympiad examination from there. So you are appearing Olympiad examination means you know something more. Not only your class level, I mean class 9 or 10 level geometry, you have studied circle and triangles, formula, theorems at least properly. So without wasting our time, let me tell you how to start problem number 2. The first geometry sum came this year's RMO paper. I'll be giving you the best solution. And solution is not unique. You can approach with different manner also. But let me start. These are two sums asked in RMO 2023. I mean, last Sunday exam was there. This was problem number 2, where they have asked, let omega be a semicircle with AB as the bounding diameter. Omega is a semicircle with AB as the bounding diameter. CD be a variable chord of semicircle of constant length. Chord variable, but its length is constant. CD lie interior of the arc AB. Okay, let us draw the diagram first. For a semicircle, the meaning of bounding diameter is this thing. AB is the bounding diameter. You all know. And variable chord. Variable chord may be anywhere like this. This is a variable chord. It may be anywhere. This may be the position of the variable chord at another position, C1, D1. that variable chord may be like this also, parallel to this diameter. Can happen any manner that C2 D2 is the position of variable chord. This variable chord lie interior of the arc AB, and they have given EB a point. This is the center. EB a point on the diameter such that CE and DE. CE is which part? This part. CE and DE is this part. D. C and D making equal angle. Obviously at this position it is not possible. Maybe it is possible here. Maybe it is possible here. So first we need to draw a diagram where it seems that at least that ED and EC making equal angle with AB. So I will be suggesting you to take the variable chord this manner, say a position of C1 D1. If you are not happy, you can change. Okay. So this angle approximately equal to this angle. So suggested position of the chord will be like this. I mean this C1 D1. Now read the question. This we are reading and writing the information here. Prove that measure of angle CED. So at this position C1ED1 is constant. And number 2, circumference of triangle CED passes through a fixed point. Here circumference through C1, E and D1 pass through a fixed point. Fixed point, you can see I have written some fixed point over there. A is a fixed point, B is a fixed point, O center also fixed point. So that circumference through CED, due to some obvious reason, will pass through this fixed point center. But this we need to prove. They asked you to prove this. How to prove it? That the circumcircle of D1, C1 and E will pass through the point O. But we'll prove it. Before that, let us know the meaning of constant, angle constant. What do you mean? Angle constant. Just let us start with this triangle. We are taking any triangle this manner. These are the angles of triangle. This is A, say this is B and this is C. These angles are known if length of sides, if you are taking this on small a, small b, small c, these are known. This is a known angle, it is constant. You cannot change. Okay. Here the problem related to the semicircle as well as the triangle C1ED. That's why I need to tell you the concept of constant angle in case of circle or semicircle. For a circle, just I tell you first, for this circle, if this one is a chord, it is a fixed length. This length is fixed. Then the angle made by it at the circumference will be equal to half the angle made by it at the center. This you all know. But provided this length AB is of constant length, provided this one is constant, you can take any position. Here, suppose the position is A dash B dash. Here also it will make the same angle at the center. What angle it measures, it makes here, the same angle will be made here. So this angle is constant. If A dash B dash was equal to AB, then the angle made by it at the center is constant. They asked you to prove that this portion, that C1D1 or CD or C2D2 at this point will make constant angle. Where? Constant angle at the point E. But is it possible? Here the constant angle was possible because A dash B dash or AB length is known and all these are radii. But how? This angle is going to be constant. because ED1 not equal to EC1. But length of C1 D1 is constant. Still, it doesn't mean that this angle will be constant. But there is one added information. You can see that this angle equal to this angle. Under this consideration, maybe C1ED1 going to be a constant angle. But that constant angle is what? The second part of the problem, they said that there is a semicircle passing through that point. So if a semicircle passes through this point, then the angle C1ED1 will be equal to angle C1OD1. Angle C1OD1 is fixed, so angle at E made by C1D1 also will be fixed. This also will be equal to constant. So let us have another diagram to understand this. So this one is the diagram where I have taken the point E. This is the center of circle. I have drawn the semicircle DCE, which passes through the point O dash, not through point O. This is our assumption. Finally, we will prove that O dash and O, or if we can prove that O dash and O are same point, then we can say that the angle made by the arc CD of this semicircle or this circumcircle, it will make the same, it will make a constant angle at CED. Due to the reason I told you. What was the reason? That if a triangle has all sides or angles known, sides and angles, or only sides are known, then you can say that its angles are fixed or constant. So to prove this, that O and O dash coincident is the main problem here. How to prove? And after proving, you will see that when you join this C2O dash and then C and O dash to D, okay? When you join this, then the angle made by CD at the point E will be equal to the angle made by it at the point O dash or at the point O. But if O and O dash constant and L is of constant length, then COD is fixed. So CO dash D is also fixed, or CED also fixed. So we will first try to prove that this O and O dash going to consider. Then we have proved that CED is constant. We have proved that CED passes through a fixed point. That fixed point is not at A or not at B, neither at A nor at B. It will be at the point O. O is the center of the circumcircle. So that is a fixed point. So it passes through fixed point. So two proofs will be done together. If you can prove that O and O dash coincident. So I just tell you again what we are going to do. We are going to prove that O and O dash coincident. CD is the length they have given, and these two angles have same measurement. Which two angles? I think you all recognize that this one, this angle, that CEA, and this one, that is DEO. They are equal, it is given. From there, we are going to prove it that O and O dash coincident. Alright. Now, this angle CEA is equal to angle DEO. You assume that this angle is equal to X. So this angle is X, this one also X. This angle is what? 180 minus 2x. Which angle? Angle CED is 180 minus 2x. Now, this is the chord. O dash D dash is the chord. It makes an angle X here. So, Now this angle is 180 minus 2x. Now on this chord O dash D of this semicircle, the angle O dash ED x lies, so O dash CD also going to be equal to x. Alright. Now what do you observe? This angle 180 minus 2x is made by the chord CD at the point E. So at the point O dash, this will have the same value, that is 180 degree minus 2x. So what do you observe? In triangle CDE, angle CDE, its measurement. What is its value? This total angle is 180 degree. 180 degree, from 180 degree you subtract x and you subtract. So this is becoming x. This one x. This angle CDO dash is also x. Now this triangle O dash CD, in triangle O dash CD, what do you observe? O dash C equal to O dash D. How? Because these two angles are equal, so these two must be same. Also we know that O is the center. Also we know OC equal to OD. So what does it mean? Both of them are lying, O and O dash, lying on this external bisector of the angle CED. I mean CED is the angle, its exterior angle is this angle x, this one also x. So both O dash and O lie on exterior bisector of the angle CED. So these two situations cannot appear where O dash C equal to O dash D and OC equal to OD. So O must coincide with O dash. This proves everything. The circle, this circle center is at O dash only. I mean O dash and O are not different point. They are the same point now. If they are same point, then CD is of constant length L. This OD and OC, they are radii. This angle 180 minus 2x is constant, fixed angle. So the angle CED is also fixed angle. And the circumcircle passing through CDE, it's true, but it is passing through this point O also, which is centered. So this is going to be the so-called fixed point. No one can change its position. That's why it is fixed point. I hope all of you have understood. You try it yourself. You need not do by this method only. You try different method. Same answer will be there. This will be a constant angle. Okay. Now let us see the second problem. In this problem number 4, second problem means problem number 4 of geometry only. Omega 1 and omega 2, two intersecting circles with center O1, O2 respectively. A will be a line such that it intersect omega 1 at AC and omega 2 at points BD, such that A, B, C, D are collinear in that order. Perpendicular bisector of segment, all these we need to draw. Okay. So you take two circles, omega 1 and omega 2. These are two circles, centers O1, O2. A will be a line that intersect. A will be a line. This is omega 1, this is omega 2, second circle. This is the line. It is intersecting at point A here, this one at C, second circle. This is omega 1, this is omega 2, second circle at B and D. Okay. You need to draw perpendicular bisector. of which point? Of AB and perpendicular bisector of CD. It will pass through these 2 points. So, if we draw perpendicular bisectors of AB, it will be line segment like this, and that of CD like this. Obviously, they are parallel because this angle 90 degree, on the same line they are perpendicular. So, remember this PQ and RS, they are parallel. Alright. Now, P and R on same side, it is given. You need to join PR. PR you join. You join QS also. Okay, QS. You join QS also. Okay. And then you need to prove that, just a minute. Now you take midpoint of PQ. Let this one be X. QS. This one be Y. Centers of two circles are like this. O1, O2 are two centers of circles, O1 and O2. Midpoint of O1, O2 you join. Midpoint of O1, O2, midpoint of PR and midpoint of QS. If midpoint of O1, O2 is a point something like this, or if you join these two, you are joining X and Y. If you can prove that this is the midpoint of O1, O2, then it is done. Okay? I think the problem you all understand. I have drawn perpendicular bisectors. This is the line segment AB given, centers of two circles given. I have joined PR, I have joined QS, and then midpoint of PR I have taken X, midpoint of QS I have taken Y. Now your problem is to prove that the line segment XY will bisect O1, O2. Okay, we'll try to prove this. So to prove this, what I did here, I have taken perpendicular from O1 to this PQ. Obviously M1 is the midpoint. I have taken perpendicular from O2 to RS. This is the midpoint. Why I am doing so? Why perpendiculars are required? Okay, that I'll definitely explain, but before that, let me draw the line joining M1 and M2. M1 is midpoint of PQ, RS is midpoint of, M2 is midpoint of RS, because I have dropped perpendicular from centers. O1, O2 are the centers. Now what you are doing there, you join. You join M1 and M2. Just join. Okay? M1 and M2 are joined. O1, O2, this line segment O1, O2 and line segment M1, M2, they intersect at some point, say T. We need to prove that T lies on XY. Then everything is done. But how to prove that T lies on XY? That I am going to explain. So first what you will do, you will draw perpendicular from O2 to this line ABCD, O1 to this line ABCD. Let this be S1 and this is S2. This put of perpendicular is S2. Now we can easily prove that O1 M1 and O2 M2, these two lines are parallel. these two lines are parallel, then parallel to this line. Okay, how to? Because this is perpendicular. If you can prove that O1 M1 and O2 M2, this angle 90 degree, because it is given O1 M1 perpendicular you have drawn. So O1 to M1 and S1 to L1 they are parallel. Similarly O2 to M2 and S2 to L2 they are parallel. So this whole line parallel to O1 M1 and O2 M2. Isn't it? Now this O1 M1, see why I am taking this diagram and we telling you again and again, because it is based on some theorem which you might have done before. Where you can have done that class 8 level. What is the theorem? That if there are three parallel lines and intercept of length K1 and K2 cut on this side line segment by these three parallel lines, then it will intersect the same length from this line segment also. Okay, I mean another way you can say that K1 by K2 equal to K1, I mean if different part is there, this part by this part will be equal to this part by this part. This you might have seen in case of trapezium also. When solving problem on trapezium, you might have seen that if there are 2 points X and Y, this is A, B, C, D is the trapezium. If AX by XD equal to BY by YC, then this line will be parallel to this line will be parallel to these two lines. This kind of thing you have seen in BPT also. Basic proportionality theorem in case of triangle. Okay, just I remind you all these things. If this is the triangle and DC parallel to BC, DE parallel to BC, then you can easily prove that AD by DB equal to AE by EC. So for this problem, what I am going to say, you have taken X and Y midpoint. So it is true that PX by XR equal to QY by YS. They are midpoints of these two lines. Which two lines? PR and QS. And these three are parallel lines. This one and this one. They are parallel lines. Why parallel lines? Because this is the midpoint. So PX by XR will be equal to QY by YS. As this is true, so XY must be parallel to PQ parallel to XY. It is parallel to RS also. Now, if you can prove that this TM1 equal to TM2, what does it mean then? This is another transversal. M1, M2 is the transversal. And where you are going to prove that M1 by T by M2 by T equal to a constant. Obviously, that Px by Xr 1:1. If you can prove that M1T by Tm2 equal to 1:1, then T is going to be the midpoint. All these things can be done. I mean, another way we can say that M1, M2 is the transversal. If T is the midpoint, then Tm1 equal to Tm2. So that line segment through X, T and Y will be, there will be only one line segment. To prove this, we take these two triangles. Which two triangles? O1, M1, T and O2, M2, T. First thing, we can easily prove that O1, M1 equal to O2, M2. How to prove? O1, M1, you can see that equal to S1, L1. This S1, L1 is AS1 minus AL1. AS1 is how much? That is, from 1 you have dropped perpendicular, so AS1 will be half of AC. And AL1 will be what? It is half of AB. AC minus AB is what? BC. So it is half BC. O1 M1 we got half BC. What about O2M2? Let us see that. O2M2 is S2L2. L2 is this point. So again, due to the same reason, this is nothing but DS2. DS2 minus DL2. DS2 is what? Half BD. And DL2 is what? DL2 is what? DL2 is half of, I am talking about DL2, it is half of DC. So again, this one is going to be half of DC. So it is obvious that O1M1 equal to O2M2. Therefore, O1M1 equal to O2M2. Now, if we go by this triangle, which triangle? In triangle O1M1T, this is congruent with O2M2T. Why they are congruent? Because you have just proved that O1M1 equal to O2M2. Isn't it? This angle vertically opposite. I mean this angle O2TM2 is equal to O1TM1. These two angles are equal. And another thing, that M1M2 is the transversal. So if this is the transversal, L1M1O, angle L1M1O equals with angle, what? This angle. Which angle here? We have taken L1M1, wait a minute. This is the transversal. So L1M1T, not O. L1M1T must be equal to what? Transversal, this angle O2M2S. No, TM2S. When you try this sum again yourself, you must draw a diagram first, beta diagram, TM2S. So if you subtract 90 degree from these two, this will give us the angle, what angle? O1M1T equal to O2M2T. So these two triangles, which two triangles? Triangle O1M1T congruent with triangle O2M2T. Isn't it? Now if they are congruent, this is proof that T is the midpoint. T is midpoint of what? T is the midpoint of M1, M2. But if X is the midpoint, then PX, XR will be same. If T is the midpoint, M1T must be equal to M2T. Y is the midpoint, QT equal to YS. So these three parallel lines, I told you, these are three parallel lines. These three parallel lines intercepted same length from PR, from M1, M2 and from QS. So T must lie here on the line XY, then only it is possible. Now T is the midpoint of M1, M2, it implies that T is midpoint of O1. Because that TO1 equal to TO2, it is proved simultaneously. And T midpoint of O1, O2, T midpoint of M1, M2, this T is this T here, which lies on XY, they are collinear. Okay? So it was a bit difficult in compared to previous one, but once you are practicing sums of this kind, you can understand, you can draw a better diagram, you can decide it quickly what is the answer to the question or prove the answer. Okay, thank you.